Hello friends, in this video we are going to discuss about the operation of a Varactor diode. Varactor diode is a linearly graded diode. Linearly graded means the doping concentration of Nd and Na in the N side and the P side of the diode will be linear with respect to the distance inside the diode. That means if we have a diode like this, and if it is the junction and if it is the P side and N side of the diode, then the doping concentration profile in the P side and N side will be like this. This is the doping concentration profile of Nd and this is the doping concentration profile for Na. Now, there will be a depletion width or depletion region, let us call it as W. The principle on which the Varactor diode will operate is the transition capacitance, that is Ct, and we know that this transition capacitance comes in the reverse bias mode of the diode. That means this Ct we know that is proportional to 1 by root over of Vrb plus Vbi, and there will be a mod and it will be cube root because it is a linearly graded junction. So, we know that since Vrb mod, that is the reverse bias voltage that has been applied to the diode, is very much greater than the built-in potential inside the diode. So, we can say approximately that Ct will be inversely proportional to 1 by cube root of Vrb mod. So, the transition capacitance of a diode is inversely proportional to the reverse bias voltage that has been applied to the diode, and that is determined by this equation. Now, the Varactor diode should be operated in the reverse bias mode because we need the transition capacitance. Now, if the reverse bias voltage, that is Vrb, is increased, then the transition capacitance, that is Ct, will be decreased as in a nonlinear fashion. Now, if I plot the reverse bias voltage Vrb and the Ct value, that is the transition capacitance in the picofarad unit, then I will get a plot like this. Ct will decrease nonlinearly with the Vrb. So, this is the CV characteristics of the Varactor diode. From these CV characteristics, we can see that for a change in the VRB, let us call at del VRB, we will get a change of CT, let us call it as del of CT. Now, for small change, continuation, from this plot we can see for a large change in the VRB, we are getting a small change in the transition capacitance. That is why, due to this property, the transition capacitance CT can be used as a capacitor value in communication system, and this is the reason why the Varactor diode is widely used in the communication system purpose. Now, the materials that are used for the Varactor diode is silicon and gallium arsenide, and the most widely used material is gallium arsenide. Next, the symbol of this Varactor diode is like this following, and this is the anode part and this is the cathode part, or we can say this is the N side and this is the P side. Now, let us take the block diagram of a PN junction Varactor diode. So, this is a Varactor diode having the junction like this, and this is the P side of the Varactor diode and N side of the Varactor diode. So, there will be a depletion layer in the P side as well as a depletion layer in the N side, and let us denote this width of the depletion layer total is equals to W, and there is a metal contact on the N side and there will be a metal contact on the P side. So, from this diagram we can see that we have to give a negative potential to this P side and a positive potential to this N side to get the Varactor diode in the reverse bias mode. Now, due to this application of the reverse bias, this depletion region will be somewhat very large. That is why we will get a CT value, that is the transition capacitance value, inside the diode. Now, this CT value depends on the width of the depletion region. Now, as the VRB, that is the voltage that has been applied in the reverse bias mode across the diode, if it is increased, then we know that the W value, that is the width of the depletion region, will also increase, and we know that the CT value is nothing but epsilon A by W, where A is the cross section of the diode and W is the width of the depletion region. That is why the CT value will now decrease. Now, we can see that by rising and decrementing the reverse bias potential, we can control the value of CT by the width of the depletion region. So, this property of the transition capacitance is used inside the Varactor diode in this manner. Now, the equivalent circuit of the Varactor diode in a circuitry form will be that there will be a series resistance Rs and there will be a capacitor value that is varying with respect to the applied reverse bias potential, and with this capacitance there will be a resistor in parallel to the capacitor, and let us denote this capacitor value as CT and the resistor value is RR, and this will be the anode section and this will be the cathode section, where this RR is the reverse resistance of the diode and the RS is the series contact resistance of the diode, and CT is the transition capacitance as we know. So far we have learned that how the capacitance value of a Varactor diode can vary with the application of reverse bias voltage. That is why the name of the Varactor diode is also called as Varicap diode or variable capacitor. Now, this Varactor diode is widely used as a variable capacitor. Without this Varicap diode, it is impossible to vary the capacitor value within the circuit itself. So, the applications of the Varactor diode are the following. The first application is that it is used for direct generation of FM, that is the frequency modulated signal in modulator circuit. Second one, it is used for voltage controlled oscillator circuit in phase lock loop or PLL circuit. The third one is that it is also used for tuning circuit or the tank circuit, and we know the tank circuit simple diagram is like this. There will be a inductor L and there is a capacitor, and this capacitor value should be varied to get different value of resonant frequency, because the resonant frequency is given by 1 by 2 pi root over L C, and if it is the transition capacitance or the Varactor diode, then we can see it will be CT. So, by changing the Varactor diode applied voltage, we can change the value of CT. The fourth application is that it is also used for fine tuning of the receivers. The fifth one is that it is also used for automatic tuning of receivers. The sixth application is that it is also used in para amplifiers or parametric amplifiers. The seventh application is that it is used for low noise microwave power amplifier. So, you can see there is a lot of application of the Varactor diode in the electronics world. So, this is all about how the Varactor diode operates and what are the applications of the Varactor diode. Thank you.